Hi everybody, in this movie I will tell you a little bit more about two basic things in car geometry, which are the camber and caster. What is the camber, how it's working, what is the caster, how it's working, how it affects the car, how it affects the geometry, how it changes dynamics, and so on. So if you want to hear about that, let's start. The first thing that I will tell you about is camber. What is a camber? So if you can see on this little picture, you got the beta angle, you got the center line on the left of the car, you got some wishbones that are marked in red, and you got the green wheel. And the camber is the angle between a vertical line, which is perpendicular to the ground. So the vertical line can be taken from, for example, from the symmetry plane of the car, or we can just imagine that the wheel is completely straight, so also the wheel is perpendicular to the ground, and we are considering the center line of that wheel. So if we are introducing some kind of angle between those two lines, so the center line of the wheel and some kind of vertical line or the plane, we are introducing camber. And the camber can be divided into three basic types. So we got the camber 0, positive and negative. 0 when the wheel is completely perpendicular to the ground, positive when the top edge of the wheel of the tire is pointing outward of the car, and the negative is like on the previous image. So the negative, the top part of the wheel is pointing inwards to the car, so to this symmetric plane of the car. What is commonly used in cars? Basically the negative camber, because it's increasing the grip. But I will tell you a little bit more about that later. When talking about the camber, we cannot see the camber as a static angle because it's changing during the suspension travel. So when the suspension is going up or down, the camber can change. This is especially for the McPherson strut suspension, where the top mounting point is fixed. It's not changing during the suspension work. We can play a little bit with that in the multi-link suspension. So we got the bottom and the top wishbone. So you can see what I'm talking about on this picture. So in this case, this is the positive camber gain. So we are gaining the camber in positive way. So we are going from negative to positive camber. You can see on the left when the wheel is on the ground, so the car is like static, we have negative camber. But if the suspension is going up, we got positive camber. Of course, this can be designed that we are just increasing the negative camber, and it can increase the grip because we are increasing the contact patch of the tire during the mass transfer in cornering. So we have to keep that in mind when we are doing the suspension design. So finally, what are the effects of using camber? So if we are considering the 0 camber, we are providing the biggest contact patch of the tire and stability, but when the car is going straight, because during the cornering, it can change. Negative and positive together can decrease the traction losses when going straight, because we are decreasing the contact patch of the tire, so we are decreasing a little bit the rolling resistance of the car. But it can introduce also the uneven wear on the tire. Negative camber can increase the grip during the cornering due to the fact that if we are going straight, we are not using whole contact patch of the tire, but when we are introducing the load transfer of the car, we can keep the biggest possible contact patch of the tire. Positive camber is commonly used in the farm machinery. When there is a loose terrain, the positive camber can help the machinery to drive on the loose terrain. What is a caster? To be honest, the simplest explaining for the caster is bicycle. You can see on the picture we are looking at the bicycle from the side. You can see that the steering wheel is behind the front wheel. And if we are considering the line going through the steering wheel and the center of the wheel on the front, you will see that this is at angle to the ground, is not perpendicular. And we are calling it the positive caster. Imagine that your steering wheel is directly above your front wheel. You will not be able to ride a bicycle in a stable manner. Even more, if you will mount the steering wheel in front of the front wheel, you will basically
not be able to ride a bicycle because the bicycle will try to turn at every single moment. And also, while using the positive caster in bicycle, you can ride a bicycle without having to keep your hands on the steering wheel. And this is the same things in cars. So imagine that we got positive caster. So positive caster is causing the wheel to come back to zero position. If we'll have negative caster, the steering wheel will try to turn even more than your input. It will not go back to the zero position. That's why we got a caster in cars. In cars overall, we can describe the caster by considering the lower and the top mounting point of the suspension, the steering knuckle, and we are measuring the angle between this line to the perpendicular vertical line going through the center of the wheel or the knuckle. And with the fact that the top mounting point on the steering knuckle is behind the lower one, we are introducing the self-aligning torque, so the steering wheel will come back every single time to the zero position. And that's why when you are going to perform the geometry of the car, to align everything in suspension, and you got some kind of, I don't know, maybe crashed car and the caster is not correct, you can feel that the steering wheel is not going back as happy as it was. So if this is the same thing as a camber, so if the caster can change dynamically, basically no. The caster will stay the same at all time, but what can change is the camber. And that's why we have to consider the caster together with camber at every single moment. Imagine the drift cause. When we got the big caster angle, like 10-15 degrees, you can see that this big aligning torque is helping to go like from the one corner to another. But you will also see when the wheel is at the maximum lock, you got the big positive camber on the inner wheel, but on the outer wheel, the camber is getting more negative. So the camber is changing dynamically, while the caster stays the same at all time. So while designing the suspension for racing cars especially, we have to consider the camber gain and the dynamic change of camber because of the caster, because it will influence the contact patch of the tire and our overall performance. So that's all for today. If you liked that video, leave a comment, thumbs up, and let's see you in the next episode.